Just a moment. Good evening. Okay. So let us start with one more problem. This is on PV diagrams. I think it appears in thermodynamics. Yeah. Of course, you can. Yeah, this question is from gas laws only. Once again, this problem is like the state of the fixed mass of gas at 350 Kelvin is presented at point A on the PV graph. So PV graph is shown over here. If the gas transforms to state B, the new temperature is. How do we solve this? Now, what happens is the students generally what they do is they just take this value PV equal to RT and they substitute it. Okay, what they do, they substitute P is equal to, what did I ask here? I asked you the gas transforms to state B at this point. At this point, now what will be the temperature? So as a result of it, they find out from the graph P is equal to 13 megapascals multiplied by, what is this, 75 centimeter cube, and then this should be equal to PV equal to RT. I said I'm going to use PV equal to RT, and as a result of it, R, which is 8.314, and then this is T. Okay, they make use of this, and finally let us find out what's the answer you get, which is 13 into 10 power 6 into 75 into 10 to the power of minus 6 divided by 8.31. Okay, let me use a calculator. Here, calculator. Okay, let me open a calculator. You can also do it at your place. Now it is 13 into 75 divided by 8.31. So I get 170. 170. Oh my God, I made a mistake here. It should have been 117. Okay, maybe it was an exam paper. So one of the options gives us 121. So usually students mark this one. This is your right answer. Now the question here is like how is this correct? The reason is because, see, this is the misconception the children have it usually. PV equal to RT is called as an ideal gas law. Ideal gas law, which means this law can be applied, or this equation can be applied only when the gas that we consider is in an ideal condition. It's an ideal gas. Okay, you might know about you would have learned about what is an ideal gas, what is a real gas. So, and that too, if it is 1 mole of a gas. But in the question, I have never said anything about the nature of the gas. See, state of a fixed mass of gas. I do not know what is the mass of the gas. I have never told you whether it is 1 mole, 1 kg, 1 milligram. Nothing has been told you, right? Is represented by point A on the PV graph. If the gas transforms to state B, okay, so pressure is reduced, volume is increased, volume is decreased. Okay, that's what has happened. And I have not told anything about here. And as a result of this, you should not use this equation. Okay, so when to use a PV law, when to use an ideal gas law, and when not to use an ideal gas law. This is a misconception. So you can use an ideal gas law only when the gas is an ideal gas. If no information about the gas is given, then do not use it. Okay. Now, if that is the case, now how do I proceed? The easiest way to proceed here is that now it says fixed mass of gas at 350 Kelvin is represented like this. Okay. And if the gas transforms to state B, the new temperature is. Now, what's happening here? Notice this. P is pressure here is 10 megapascals. Now, pressure is increased. Corresponding to 10 megapascals, volume was 100. And when pressure is increased, volume is decreasing. Which means what? Which means P is inversely proportional to V. That's what is happening here. Okay, you might always argue saying, say, how come that I have put a straight line here? This is a state diagram. Okay, state diagram, I can put a transition there. Nothing wrong. Okay, so therefore, so P is inversely proportional to V here, which means what is this law called as? This law is called as Boyle's law. Now, when does this law appear? When can we use this? This rule is applicable when the temperature is equal to a constant, right? I have increased the pressure, and as a result of it, volume has reduced. Can you think of the situation? Situation like this. Okay, you have a cylinder containing gas. How much was the cylinder containing gas? Initially, this was 10 megapascals. 10 megapascals was given. Okay, and the volume here was 100 cc. This was the height of the cylinder. Now what did you do? You increase this, which means you added chota mota weights here. Small weights you added. So as a result of it, what happened to this piston? The piston went down, right? It went down, which means the height has now reduced. This is a new height. And the height has reduced, area is same, which means volume has reduced. See, volume has reduced over here. Same thing has happened. And this will happen only when temperature is a constant. Okay, or we have done this experiment and temperature to be a constant. So thus, you should not use this while temperature is constant here. And as a result of this, okay, you should only say that T should now be equal to 350 Kelvin only. Okay, this is one way of doing it. Now what we'll do is, if this rule is correct, now it should obey Boyle's law. What is Boyle's law? Boyle's law says that P1 V1 should be equal to P2 V2. Okay, see, even now you cannot directly employ this. Okay, you should think about this. P1 V1 should be equal to P2 V2. Let us do this. What is P1 V1? P1 V1, 10 into 100. See, this is your P1 V1, right? This is your P1 V1. 10 into 100 should be equal to 1000. What is P2 V2? 13 into 75. Okay, this is your P2 V2. So this should be 13 into 75. Just find out whether, not 175, 13 into 75. Just find out whether 13 into 75 gives you the same answer. 13 into 75. It gives you 975. Gives you 975. So which is very close to what is given here. So therefore, Boyle's law is applicable. Okay, so which means the temperature does not change. Very simple. Okay, so what do we need to know here? We need to know what is the type of variation here. Okay, first thing is you should not apply your ideal gas law. Second thing is, if you cannot apply ideal gas law, how do I determine the temperature? To answer this, first you verify what kind of law does it obey. So if I look at the axis and the way, the trend line, how does it vary? You can very clearly say that, okay, as the pressure increases, volume decreases. That's what you can say. Now, we find whether Boyle's law is verified in this case or not. So as a result of it, I took the product of 10 multiplied by 100 and 13 multiplied by 75. So these products were seen to be equal, which means throughout the graph, your pressure multiplied by volume should remain a constant. Only then your Boyle's law can be applied. Of course, it remains a constant. And thus, now I can say that the temperature remains a constant. Thus, what is the right option? The right option is E. I hope you like this video. Thank you friends for watching. Like, share, comment, and subscribe to my channel for all your further updates. And if you want any particular problems to be solved, you can actually put it across. Thank you.